Well, good morning and welcome to Tesla Northwest and EVs. I'm so glad you could join me. What are we going to do today? Well, as promised, I am going to be installing a Tesla Generation 3 electrical vehicle servicing equipment, or better known as a charger. The charger is actually built into the cars, but that's for a different day. So why don't we go through the whole process? I'll talk to you about what materials you need. I'll show you what I currently have, and then we'll start from the beginning. We'll do a breaker swap out. We'll pull out my old stuff, we'll put in the new, and then we'll wrap it all up. So please join me as I show you how to safely install a level 2 Tesla Generation 3 charger, but this really would apply to just about any EV charger for most of the installation that I'm going to do. So thank you, and I'll catch you on the flip side. Hey there, welcome back and thanks for joining me. So what we're looking at right now is my current setup. So I am using the Tesla mobile charger. This outlet was here when I moved in, 50 amp outlet, little bit of a ghetto installation, but it works and it's within code, at least when they did it. And then my panel. So we are going to be replacing this 50 amp breaker right here. With a 60 amp, and then we're going to go over what we've got. So here is my supplies. We're going to talk about each of these in turn, but I've got a Tesla Gen 3 charger. Everything you need comes in the box, so just order the charger. You don't need the other stuff that they have on their site, and I'll talk about that. Got a brand new 60 amp breaker. We've got a 4-square box and cover. I've got a heavy-duty industrial-grade NEMA 650 outlet. Very important that we buy heavy-duty and we buy brand new. I've got what are known as split bolts, and I'm going to be using these instead of wire nuts. They do a much better job, in my opinion, and we'll talk about why I like these over wire nuts in some instances. And then we've got our miscellaneous hardware. And lastly, I'm going to be using what's known as MC cable, or metal-clad cable. And here is a quick look at the tag, and it is what is known as 6-3 MC. So it is a number 6 wire. There's 3 conductors and 1 ground. And then here's my list. So as you can see, the Gen 3 is $350. The 4-square cover, I really think you should get metal for safety. And then our wire is rated at 75 amps at 90 degrees Celsius, and we'll talk about that as we do the install. Brand new breaker, and then split bolts and miscellaneous and tape. And then you can see, as far as tools, I've got gloves, non-contacting voltage tester, miscellaneous different hand tools, and tape measure. All right, so that is what we need to get started. And as I always tell my students, be prepared. So you want to have all of the stuff you need to get started before you get started. So that's what we are doing there. We're going over it. So as we do this install, I'm going to talk about how to do things safe. And I'm going to talk about the way I go through it as an electrician and an instrumentation and electrical instructor. So thanks for joining me, and we're just going to keep on trucking along. All right, I think we are ready to get started. So the first thing we have to do is take our panel cover off, replace our breaker, and demo out our old installation. And how are we going to do that safe? Well, we are going to disconnect power for the entire panel. I think this is the safest way to do it, and so that's how I'm going to do it. Now, I've already gone inside. I've made sure most of everything is shut off. Nobody's in the middle of anything, and there's no heavy loads running like the dishwasher or the dryer, washing machine, vacuum cleaners, etc., etc. So that is a good thing. You want to shed your loads. Make sure everything's turned off as best as possible. A few things aren't going to matter, but you don't want to have a lot of stuff running when you throw your main disconnect. So I'm going to go ahead and shut off the power to the house. And we have now rendered this panel safe. I have what's known as a non-contacting voltage tester, and I'm going to use that to help me verify. But first, let's go ahead and pull this panel cover off. Now, you don't have to necessarily kill the power to take this off, but I'm already going to be in here working, so I may as well do it as safe as possible. All right. And we aren't going to work the whole time with our main breaker turned off. But I want to make sure that I get in here, get my demo done, and get my breaker replaced with things as safe as possible. I don't want to be digging around inside of a hot panel, if you know what I mean. So we just about got this cover off. And why am I replacing the breaker? Well, currently, This is a NEMA 650 outlet, and it's connected to a 50 amp breaker. Okay, carefully wiggle your panel cover off, and there you go. Now you've got an exposed panel. We'll just set that off to the side, and we can see now we have access to everything going on inside. And I'm going to use my what's known as a non-contacting volt tester, or as a wiggy, making sure it works. I've got power on top. That makes sense. This is my incoming line from the service side, so I should have power here. But because I've opened my breaker, this should be dead down here. And I can see that I'm not getting anything. I move back up to verify, and I come back down here, and indeed the power is dead. And then I can just run through these, and I can verify, yes indeed, it's all turned off. So next thing we're going to do, we will unplug our mobile service equipment. Thank you very much for a lot of great charges, but we are going to retire you for another service. So now what I'm going to do, I'm going to get in here and I'm going to replace this breaker. So I will show you that process in just a second. All right, and there's the 50 amp breaker in question. How do I know it's a 50? It's labeled on the handle. It'll say 50 right there. So we're going to disconnect those two wires, and we're going to remove that breaker from our panel. And again, that was my main. I tested on the top, and I tested on the bottom to verify no power. Okay, so let's go ahead and pull our breaker out. All right, folks, we're going to go ahead and pull out our breaker. So we're going to get some tools. We're going to look here first. My ground has come off. It was connected by a wire nut. That's why I don't care for them so much. And honestly, not a very big ground. Here is our wires in question. Again, we're going to verify that we don't have any power. Good. We're safe. I always like to double check that kind of stuff. All right, so we're going to get in, and we've got a nice big fat screwdriver, and we're going to loosen up our connections here. Sorry, my head's probably in the way. All right, and there, folks, was what was running to our outlet. So we've got that disconnected. We're going to get it out of the way, and next thing we're going to do is replace our breaker, and it should just pop off. So you can see that, folks. It popped right off. So slides in to the tabs, and then it pops in. So we're going to pop this one out. And again, this was a 50, and we're going to replace it with a 60 amp breaker. So here's our 60, and we can see we've got our tabs. So we just line it up, and hopefully this is the right one. And sure enough, it is. Pops right on in. See that, folks? Nice and secure. I've got this turned off. I've got it disconnected. I'm going to pull this out, and then I'll power the rest of my panel up, but leave this breaker turned off while I do the rest of my work. All right, I'm going to start demoing this stuff out, and the reason why I like everything turned off again, folks, is because this wire is kind of moving around in the panel, and I don't want it to hit anything as I try and pull it out. So bear with me. I'm going to remove a couple screws, and we'll keep on trucking. All right, and there we can see it has been successfully pulled out, and we've got our nice new 60 amp breaker. So we're going to go ahead and start running our MC cable, and I will bring you that cool process. All right, hey, welcome back, folks. So I'm getting ready to run my MC cable. Remember, it's 6'3" copper MC with a aluminum jacket. Why do I like this? Well, because it saves me from having to run conduit too. This is a very, very good option, but it's expensive. It's over $6 a foot, but I didn't want to run conduit. As much of an electrician I am, I hate running conduit. So this saves me from that because it's already in its own conduit. So how do we get it unwrapped, you might ask? Well, you can buy a special tool, but I just, wearing gloves, because you want to be careful, just slowly work this jacket off. So I'm just working it around, being careful not to nick my wires, and I'm going to expose eventually enough that when I come up into my panel, I only have wire coming up and not the metal. So that's the idea. So I'm going to go ahead and unwind this, and I'm going to push it up into the panel, and then once I'm there, I'll get back with you. All right, and we've got it unraveled, folks, as you can see, and I'm just kind of measuring it by holding it up here, and I can see that when I bend it, it should reach. So I'm working in the dark a little bit. I'm going to get this landed and get the power turned back on for the rest of the house, and then we'll get these wires ready. And I'll talk about why I chose this wire a little more besides the metal cladding. All right, folks, we've got our wire into, and it's nicely secured inside of our panel. I haven't stripped it yet. What have we got here? Like I said, this is called 6-3 MC, so I've got 3 conductors, 1, 2, 3, and a ground. The ground is never counted when they talk about the wire. So like Romex or other types of wire, when they talk 2, 3, etc., the ground is always included. I got an extra, just in case someday I want to add a NEMA 1450 outlet, which has a neutral. So I just future-proofing my installation. So I'm just going to fold that one out of the way. And then I'm going to find a nice heavy ground to connect to inside my panel on this side, and then connect these both to my breaker. So I'll check back with you in just a minute. Okay, folks, and there you go. We are landed on our new 60 amp breaker. There's my split bolt. I'm using it to connect to my ground, and then I ran my ground up and connected it up here to my neutral bar. So everything is very, very well grounded and connected, and I'm going to get ready to turn the main panel back on. Okay, folks, we have successfully pulled out our 50 amp breaker, demoed our old outlet, installed our new 6-3 MC cable and our new 60 amp breaker, landed everything, and we've got our panel back on. So we want to notice that my breaker is still turned off. I used my non-contacting voltage tester again to make sure that my wire here is safe. So it is all dead, and we're going to close this panel door so that nobody messes with that breaker. It's turned off, and I'm literally 10 feet away from where I am working. You probably want to lock it out if you can't have line of sight on what you're doing, or wait to land those 2 wires till the very end. Either way, you're the one working on it, so you want to make sure it's not hot. So we're going to go ahead and run this over to where I'm going to mount my box, and I'll catch you on the flip side. And when we start mounting the box, I'll talk about why I picked this wire and also the requirements behind the charger as far as ampacity goes, and what the references and codes that we need to know about as well when we do this. So catch me on the flip side. I'm going to run some wire. Thanks a lot, folks. All right, folks, and through the magic of television, we have our MC cable ran. It hides back behind the garage door, comes around, and I'll show you that, and then we run down the wall here, and we're going to come to our box, and I've got my handy-dandy torpedo level. No good electrician leaves home without it. So we'll go ahead and start making this up, and then I will talk about split bolts and the wire when I do. All right, folks, and there is the initial mounting box that you're supposed to install. So this is the Tesla back part of the Gen 3 charger. So I've got that mounted, and then on this side here I've got my wires in and my box. And I was going to add a NEMA 650 industrial outlet just in case, but I think because my box is kind of small, I'm just going to go straight through, and then this is future proof, so if my charger ever fails, I can add the outlet. So I'll check you on the flip side once I do a little bit more work here getting things installed. All right, and so there is the box all mounted and tightened. We got our zip tie. There's our outside cable. And if we come around, then we can see our inside box. And again, I'll show you the conduit work when we're done, or the cable, and then where we come back out. And we are going to use some split bolts, and we're going to do the splice now. So I'm going to show you that. But one thing I wanted to talk to you about real quick before we get there, here is the equipment that I took out. Well, this was the one I was going to put in. This is a very nice heavy-duty NEMA 650 outlet. However, what was in was this, not very heavy-duty, and that is what's known as Romex, folks. And Romex is not rated higher. This is number 8 Romex, and it's rated at 55 amps. So it was okay because it was on a 50 amp breaker, this old one we took out, but we couldn't use Romex to run our level 2 big charger on the 60 amp. And I'll talk about that when I start making up my splices. So thanks for joining me, and I'll catch you when we're making up some splices. All right, hey, welcome back, folks. So as you can see, I've gotten some work done while you were away. I have got my wires all ready to go, stripped and paired, as you can see, and I use a little bit of tape just to keep them close. Now, I did want to talk a little bit about why we're using... Oh, shit, sorry. Oh, boy, the joys of video. Okay, there we go. I did want to just talk briefly, God, sorry, about why I'm using number 6. So you want to make sure that you are always checking your National Electrical Code. That's what I'm using. I'm also using Washington Administrative Code, and I'm using the Revised Code of Washington. So you always want to make sure you're checking with your authority having jurisdiction, you get your permits, and you check all of the applicable codes, including reading the manual about what it is you're working on. So I can't stress that enough. Couple things to be on the lookout for in the NEC. Article 625 deals with electrical vehicle servicing equipment, so you should check that. You should also be checking table 310.16. That talks about your ampacity levels for your wire, and it's how I know I can use this number 6 THHN MC cable, and it's rated at 75 amps at 90 degrees Celsius. That's from my ampacity table. And I also know that number 8 Romex is rated at 55 amps for my ampacity table. Also, we're using copper. I always want to use copper. Why? This is an important fact, folks, is our electrical vehicle servicing equipment, our chargers, on the Teslas, it's an 11.5 kilowatt charger, needs to have 125% capacity because it's a continuous use device. Your car charger is probably one of the highest consuming devices in your home. It's going to use a lot of current, and it's going to use a lot of current over a long period of time. So you want to be sure that you are using this 125% extra rating. That's why the Tesla charger is a 48 amp charger, but I'm wiring it up to a 60 amp breaker. That's 125%, 12 amps over. And my wire at number 6, giving me 75 amps, gives me lots of buffer. So we want to be sure that we're using copper. And why copper? Because copper doesn't expand and contract like aluminum does. Aluminum gets hot, cools down, gets hot, and it will loosen up over time. Copper will do the same, but not as bad. It has a smaller expansion coefficient. I will still come back and check these after 6 months, but with aluminum, oh yeah, they would definitely come loose quick. So make sure you're checking all of your tables, your wax, your NECs, and you know what you're doing. So we're going to go ahead and make these up with some split bolts, and I'll check back in with you in just a minute. Thank you so much, folks. All right, so let's go ahead and install our split bolts. So what is a split bolt? And you know, I'm sorry about the camera work here, folks. I'm doing this solo, so you're just going to have to bear with me, and if nobody watches, that's okay, but I promised I would do this. This is a split bolt. And why do I prefer these over a wire nut? Well, I'll tell you, wire nuts can come loose. Split bolts won't. And the great thing about a split bolt is it slips right up over our wire. Whoop, if I don't drop it, it slips right up over our wire. And then we've got this other handy dandy little piece here that helps compress it. And then all I have to do is come back and insulate this. And that is what I'm going to do with some shrink wrap and some electrical tape. So we just, again, we slide these guys on here, and I love these split bolts because they create a very strong mechanical splice. And as much as I don't like splices, right, we're future-proofing this installation. So we wanted to make sure that in the near future, oop, I put that on upside down. In the near future, if we needed to, we can update this. Everybody's like, oh, you're blocking your light. And again, mechanical connection, very sturdy. So once we get that on there good, we just tighten it down. This is probably where I should have some time lapse, huh? So I'm going to go ahead and make up the rest of these, and then I'll show you how I insulate them. All right, folks, and there are those beauties all made up. So those are split bolts, and they are very, very, very tight. And now what I'm going to use is some shrink tube and some tape to insulate them, because you've got to make sure these are insulated. The shrink tube and tape make them a little bit hard to maintain, but it will definitely be good insulation. And these are very, very tight, so I will check them probably in 6 months to a year. So I'll have some extra heat shrink. So let's go ahead and do that, and then I'll be right back with you. Okay, and there is our heat shrink tube. I'm just going to insulate the two hots, and then I put tape on the ground. So we'll get a shrink gun, and we'll shrink those down. Hopefully you all are appreciating this. I know it's not the most high quality install, but it's from the heart, right? So I'm sharing with you all of the tricks that I know and my trade secrets. Again, what makes me qualified to do this? I was a licensed Washington State electrician. I teach instrumentation and electrical at Bellingham Technical College. And frankly, folks, I did it for 20 years in oil refineries. So I got a pretty good idea what I'm doing, so you can trust me. Some of the stuff is a little bit Mickey Mouse because it's, you know, what I have. But again, I'm following code, the National Electrical Code, Washington State Revised Code, and everything else my authority having jurisdiction tells me to do. So let's go ahead and shrink tube those, and then we'll check back in. Hey, all right, and there we go. We can see those are all nice and shrink wrapped. I'm just going to put a little tape over the ends, but I like to leave a little bit of extra on the ends so I can get in there with a pair of scissors and cut those off when I need to. So we're going to go ahead and put that away and put a cover on there, and then we're going to go ahead and clip in our charger, and then we should be ready to go. So check back in just a minute, and I just appreciate everybody who's joining me. All right, hey there folks. Well, guess what? We're done. So we're going to go ahead and turn the breaker on. We're going to see what's happened, and then I'll walk you through, or at least talk about how you get connected to your Tesla Gen 3 EVSE. So let's throw that breaker and see what happens. Hopefully no sparks fly. All right, the breaker's holding. So far so good. Let's see what we see over here on the charger. All right, look at that, folks. We've got a green light. Oh, we've got all kinds of green lights. All right, folks, so here's the final install. Breaker's on. We've got good success. We ran our MC cable up and over. We came down here in the middle between our garage doors. We made up a splice to future-proof in case our charger fails or we need to add an outlet in the future. And remember, folks, we use split bolts and shrink tube to insulate them. We punched out of the hole, and we came around, and there is that beautiful EVSE Gen 3 sitting there ready to plug in. So let's see how what the process is to get connected via the Tesla app, and I'll show you that on camera. Hey there, folks. So we are attempting to connect to the Tesla wall charger. So I've got my phone out, and it's offering me an option of Tesla wall connector. So I'm going to select that to connect. And enter password, it says. So I need to find the password. And the password is on our directions, and the password is... you know what? I'm not really sure. Okay, so let's take a look here. I've got a QR code on the front of the instructions, so we're going to try that. No. Okay, we're going to duck out of here for a minute. All right, hey, I'm back. So I finally figured it out. So you need the QR code on the front. You scan that with your camera, then it automatically connects you through the Wi-Fi. Then once you're connected to the Tesla network, you click on it and you get this screen, which gives you a bunch of options and things to pick through for your charger. So that's what I'm going to go through now. I'm going to get it all set up, and I'll check with you in just a minute. All right, folks, we're wrapping up. So I was successful. I got everything connected. Basically what you do is you go through a, basically you manage the router through that internet connection for the device. And once you're in the device, what it lets you do is select your internet connection. So I'm now connected to my home internet, so it'll download and install updates just like the car. It also asks you to set your breaker size, so 60 amp breaker. That way I get the 48 amp max. And then I can also set permissions. So I can only let certain vehicles charge, or all vehicles. I let all vehicles charge, why not, right? And you can do power sharing, which I don't need. So I've got everything set up. The app is ready. Let's see if we can successfully get Amos plugged in, and then we'll call this a wrap. So come along, folks, as we try out our new charger. All right, so here it is. We've got all these beautiful green lights. Oh, I'm gonna need my phone so I can get in the car. All right, let's try this out. I'm excited. I've been wanting one of these for quite a while. Sorry about the camera work here, I'm by myself. Okay, let's see. Moment of truth. Oh, maybe I gotta unlock the car. Okay. Now we should get it. There we go. She's open. Oh, we've got a green light. That's looking promising. Let's see what the screen says inside. All right. Charging equipment communication latch. Check power source. We'll close that. Oh. Let's pause that. Oh, no. Pause. All right. And we can see that if I wanted to charge, I could. And everything seems to be happy. Charging equipment not ready, it says. Let's find out what's going on. Okay, I'm gonna check it out. I'll be right back. All right, I had to do the standard unplug, plug back in thing, but we can see everything is working. We're climbing up. 27, 29, 31, 32, 33, good. So I am very, very happy with this installation. Folks, I hope you found some value in it. It's a little bit disorganized. I apologize again. I'm kind of doing this by myself, and I'm not a professional. I'm just trying to help people out and have fun while I do it. So I hope you have a wonderful holiday. I hope this helps you out, and I'd love a subscribe and a like, and I'd love suggestions on making things better. I'm just trying to have fun, and I'm hoping to bring you along with me. So thank you so much, and just have a wonderful day. And let's end the video with this beautiful 48 amps of charging. All right, folks, have a wonderful day.